Hi kids, let's talk more about redox in terms of electrons transfer. Now, you can see these elements here, fluorine, chlorine, bromine, iodine. They're all part of group 7, the halogens. Now, what happens is all of them have 7 valency electrons and all of them want to get one more. But who wants to get it more? So let's look at it this way. Now, fluorine is father, chlorine is mother, bromine is brother, and iodine is you. Okay, now all of you are trying to play basketball. And what's the concept of playing basketball? Everybody tries to get the ball. Now, so let's see. Fluorine, chlorine, bromine, iodine. Who's the one who's the highest chances of getting the ball? Of course, fluorine. When fluorine catches the ball, fluorine is no longer fluorine. In fact, now fluorine is called fluoride. Okay, now let's say there's another ball. Will fluorine get it again? No, because fluorine has already a ball, has already an electron. Fluorine is now fluoride. It's not interested in reacting anymore. Okay, so let's say there's electron, there's a ball, and by some miracle, bromine got it. And now bromine has changed to bromide. So, iodine says to bromide, can you please give me the electron? Please give me the ball. Bromide says, no way, short stuff. So what happens is, chlorine, remember, mom, says, give me the ball. And bromide says, okay. So bromide gives the ball to chlorine. And now chlorine is no longer chlorine. Chlorine is now chloride. And bromine has formed again because bromide has lost the ball and now has turned back to bromine. So this is called displacement. A more electronegative, a more reactive halogen can take the electron away. But you have to understand, the only one that can take the electron is the one that is an element. For example, if there's another electron now, chloride already has an electron. It's not going to take it anymore. Bromine or iodine are the only ones that can take electrons. Bromine can take the electron away from iodide. Let's say here's an iodide ion, and bromine says, give me the electron. Iodide has no choice. Iodide has to give the electron. Okay, now where do we apply this? Sometimes you will see a question like this, where they just give you something like this and they ask you, is this redox? Of course this is redox. How do you know? Okay, so let's see. What is chlorine water? Chlorine water is not Cl2 plus H2O. Chlorine water is just Cl2. It's called chlorine water because it is a solution of Cl2 in order to react. But the equation, we just write Cl2. Okay? Potassium iodide. In potassium iodide, it is not iodine. It is Ki. And in Ki, it is a potassium ion and an iodide ion. Okay? So, who is holding the electron now? The one that is holding electron now is iodide. Who is more reactive? Who is taller, chlorine or iodine? Chlorine. Can chlorine take away the electron? Of course. So what happens is, chlorine says to iodide, give me the electron. And what does iodide say? Okay. So chlorine takes the electron. And this is the half equation for reduction, because it is gain of electron. Okay, now what happens to poor iodide? Iodide gives the electron, says take it, take it, take it. So in this case, iodide loses the electron to become iodine. And therefore, this is an oxidation half equation. Okay, now if we take the two half equations and combine them together, that is called an ionic equation. Now, how do we do an ionic equation? It's very simple. We pretend that it's like simultaneous equation for math. The arrow is equal sign. So everybody behind the arrow sign goes together. Everybody in front of the arrow sign goes together. And in the front we have 2 electrons. At the back we have 2 electrons. We can just cancel them up. Like that. Okay? So we combine the equation together. Cl2 plus iodide becomes 2Cl negative plus iodine. This is called an ionic equation, and it is a redox reaction. Now, you notice that somebody is not here in all these equations. Who is not here? Potassium. Potassium ion basically doesn't do anything. The ion that doesn't do anything is called a spectator ion. And we don't put in a spectator ion in an ionic equation. Alright, so what if the question were to ask you for a chemical equation? Then you can put the spectator ion in. So it becomes chlorine plus 2 potassium iodide becomes 2 potassium chloride and iodine. So this is called a chemical equation. So half equation, half equation. Ionic equation, chemical equation. And what would you see in this reaction? So you have to understand, you are looking at the test tube. Potassium iodide is colorless solution. It changes to iodine, which is brown. So the color changes from colorless to brown. Okay? Alright. What about this? Take a few minutes to look at it. Will anything happen? No, because bromine is less reactive than chlorine in sodium chloride. Here, chloride is already holding the electron. Chloride is happy. Chloride is not going to let bromine take the electron because bromine is lower. So, no reaction, nothing happens. Okay? So, keep on practicing and I'm going to show you more examples on how to write equations for redox. See you!